Welcome to this video on type coercion and casting. We will explore how data types change during program execution. In programming, data can be of different types, and sometimes these types are converted automatically, called type coercion, or manually, which is explicit casting. Let's understand the concept of type coercion. Type coercion happens when a value changes from one data type to another automatically during program execution. In this example, we are adding an integer and a real number. The integer value is 8, and the real value is 2.5. When these two values are added together, the programming language automatically converts the integer 8 into the real number 8.0. After conversion, the calculation becomes 8.0 plus 2.5, which gives the result 10.5. This process is called automatic type conversion, or type coercion. Now, let's look at how it works step by step. First, the program detects different data types in the expression. Next, coercion happens automatically, so both values become the same type. Then, the operation is performed using compatible data types. Finally, the program produces a real number result. The visual example at the bottom shows how the integer 8 changes into the real number 8.0 before the addition takes place. Key points to remember. Type coercion helps programs work smoothly with mixed data types. It happens automatically in many programming languages, and it is commonly used in mathematical calculations and expressions. So, in short, type coercion automatically converts one data type into another to make calculations possible. Let's learn about automatic type conversion. Automatic type conversion happens when a programming language automatically changes compatible data types during calculations. In this Python example, the variable x stores the integer value 1. The variable y stores the real or float value 2.25. When the program calculates z equals x plus y, Python automatically converts the integer 1 into the float value 1.0. Now both values are floating point numbers, so the calculation becomes 1.0 plus 2.25. The final result is 3.25. Notice that the output is also a float value, because one of the numbers in the calculation was a float. Now let's look at how the process works step by step. Step 1. The program detects different data types, an integer and a float. Step 2. The integer is automatically converted into a float. Step 3. The calculation is performed using the same data type. Step 4. The result is produced as a float value. This process is also called implicit type conversion, or type coercion. Automatic conversion makes calculations easier because the programmer does not need to manually convert the values. Some common automatic conversions include integer to float and integer to complex numbers. Key point to remember: the result usually becomes the wider or more precise data type. So, automatic type conversion helps programs work smoothly with mixed numeric data types during calculations. Now let's understand the conversion diagram. This diagram shows how data changes from one type to another during program execution. At the top, we can see the conversion flow. The value starts as a string, 15. Next, the program converts the string into an integer value, 15. Finally, the integer is converted into a real or float value, 15.0. This process is important because computers need the correct data type for calculations. Now, let's look at the detailed example step by step. Step 1. The value 15 is read as text, also called a string. At this stage, the computer treats it as characters, not as a number. Step 2. The string is converted into an integer. Now the value becomes a whole number that can be used in calculations. Step 3. The integer is converted into a real or float value. This allows the program to perform decimal calculations accurately. The example in the middle summarizes the process clearly. String 15 becomes integer 15, and then becomes float 15.0. Now, let's understand why conversion is needed. Programs often convert data before calculations.